We are on 33.2, page 968, learning about the nervous system. Yesterday we learned how nerves send a signal from one place to another, and
it keeps sliding down.
The nervous system is basically divided up into two sections. We have what's called the central nervous system, which is the brain and spinal cord. That's the central nervous system. The peripheral nervous system, peripheral means on the outside, is everything that comes off of the brain and spinal cord. Nerves that go to the side like that. And there's also some coming off the brain that go into the face and mouth and nose. Little nerves, they aren't showing them here, that would go into there. These yellow things are all nerve fibers. A nerve fiber consists of maybe hundreds or even thousands of those little axons that we studied yesterday. The little things that send the electrical signals. They're like wires. These are like phone lines almost, that come down and spread out and eventually branch off and go to each area of the skin or inside the body. Now, here is looking at the brain itself, and the brain is actually divided into two halves, the left hemisphere and the right hemisphere. And if we tear that apart and look inside it, you can see that there are different sections to it. And those sections have names, and you need to know those names.
Okay.
And so here we go. We have, this is your spinal cord coming up like this, and then you have an area here called the medulla oblongata. This area here, this whole part right here, this is called the brain stem. If this were a brain flower, I'd be holding the brain stem.
So that's the pons and medulla oblongata?
Yeah, the pons and the medulla oblongata and also up here are considered the brain stem.
Okay.
And the brain stem controls basic activities that you don't even have to think about. It controls breathing, heart rate, sleeping, waking, being hungry or thirsty, all of your emotions, fear, anger, happiness, sadness. It's all in the brain stem. So, sex drive is another thing in the brain stem.
Good movie.
So this controls your basic activities that you don't even have to think about. And specifically, listen, the medulla oblongata controls breathing and heart rate. Those are the two things you have to know for the test. Medulla oblongata controls breathing and heart rate. You probably heard that term before on Billy Madison or something. They were talking, or Waterboy, I'm sorry. They were talking about the alligator is ornery because of his medulla oblongata, and that's because, like I said, the brainstem controls emotions, and one of the emotions is anger and fear, and that is in here too. It's all spread out. The pons helps control breathing as well. So breathing and heart rate here and here. The hypothalamus is a special part of the brain that sits right above this little gland here. You may have heard of that gland before. It's called the pituitary gland.
Yes.
And the pituitary gland is the master gland. It sends out about 8 different hormones that help the body work. And the hypothalamus controls the pituitary gland. So that's a very important region of the brain. It helps control hunger and thirst, sleep and wake. It helps in a lot of blood pressure, things related to homeostasis in the body, keeping the body constant and even. Now this big pink part of the brain up here, that's called the cerebrum. Cerebrum, you see that word up there on the top right. That's where the conscious part is. That's where the thinking occurs. That's where you control a whole bunch of things go on there, like memory, your personality is in there. when you can create a muscle movement that comes from the cerebrum. When you're just remembering something, memory is somewhere in that cerebrum. Our cerebrum as humans is very large. We have a huge cerebrum, humans do. If you look at the cerebrum of a snake or a fish, it's real tiny. There's hardly any of that pink layer. It's just this tiny layer that's right on the outside of this. But in us, it's huge. So we do a lot more thinking and memory and conscious activities than they do. Yes, Program.
Is that where problem solving is, or?
Problem solving is in the cerebrum.
Mr. Willis?
Yes.
So when we go unconscious, what exactly does that mean?
On what? Unconscious?
Yeah.
That means this part of the cerebrum is not really doing much. Everything is in here. Everything is, here is still working even when you're asleep. There are things going on in here controlling your breathing and your heart rate.
What about
dreaming actually goes on in here too. And some parts of the cerebrum are active when you're dreaming, but not much. Drew, stay with me. Yes?
So when you're dead brain...
You got this, Joe.
Brain dead?
You got this.
Brain dead means this part of the body, all of this part has died. It hasn't got enough blood or something like that, and all the cells have died. Your brain no longer works. The other cells in your body can be kept alive if you're on a machine that will keep your heart. Your heart doesn't need the brain to beat. The heart needs the brain to control how fast it beats, but the heart will beat on its own even without the brain.
Can the brain start working?
No, almost never. Maybe there is a case or two where it's come back somehow, but I don't think so. Once the cells have died, they're gone. So people who are brain dead have their heart still beating, and they're on a machine that keeps their lungs working, and so the other cells in their body are still alive.
Like Terry Schiavo?
Who?
Terry Schiavo.
I don't know.
Doesn't put the plug.
The vegetable lady.
So basically what you have to do, that person will never think again, and usually the family decides to pull the plug, which means unplug the machine that keeps their other cells alive.
With Terry Schiavo, it was like a big deal with it. They should pull the plug
It was
now.
on the news like 6 years ago.
Every day.
Yeah, like
Now,
literally every day.
The cerebellum is a part of the brain toward the back that controls muscle coordination, whether your muscles can work together or not. And the thing is, when you're swinging, hitting a pitch, or throwing a ball, thank you, hitting a golf club, when you're doing these things, you have to coordinate the movements of many different muscles. Remember, you have 600 muscles. And so if I'm sitting here doing jumping jacks, and I'm going to do it correctly, or if I'm going to stand on one foot and touch my nose, woohoo! I've got to put about 100 or 200 muscles working exactly together at exactly the right time. Huh?
Oh.
Wax on, wax off.
And that takes a lot of coordination, and that's done in the cerebellum. 2-year-old kid couldn't do what I just did. They haven't practiced it enough.
Cerebellum.
Yes.
This is like control the balance.
Yes.
I knew somebody that had to have a ball put inside the right side of their head because their balance got thrown off. Like, what is that?
Really?
Do you know?
I have no idea.
Like, really? That's a lot. No, they
walking
around.
You can see the cerebrum has been charted. What part of the cerebrum does what? We know vision is in the back. We call that the occipital lobe. And you don't have to know all this. This isn't even in your book. But I thought you'd be interested. The vision is in the back of the cerebrum. Understanding what you're looking at. This area here controls speech. You can see speech. And personality is up here. And hearing is right about here. And this area right here controls the legs, this controls the trunk, this controls the arms, this controls the hand, this controls the face, this controls the tongue.
Wait, the trunk?
Taste is right there.
Is this like an elephant or something?
This is a human.
What's the trunk?
What's the trunk?
The trunk of the body is right here. Yes?
How much, percentage-wise, how much more brain does the human use? I read somewhere.
How much more brain does the human have?
No. Do we use? Do we use?
We use it all.
Okay.
We use it all. That's a myth, saying we don't use 90% of our brain. That's not true.
Yeah.
Will you turn that back this way?
Yeah.
It's very confusing when you're watching it.
Well, he asked the question, so I was trying to get him on.
That's what I point.
Yeah, that's just a myth. We use all of our brain. We have a brain that's 4 times as big as any other animal.
Yeah.
So if you think about it that way, we use a lot more.
Where's memory?
Memory is all over. And we still don't understand how it works. But when you remember something, like think about your mom's car. When you're thinking about your mom's car and you're bringing up a picture that you got information coming from here, you got information coming from here, from there, and somehow it all comes together to make a picture of the car. And we don't know how that works. That's one of the things they're working on. I'm sure they'll figure it out one day. But it's very complicated. The brain consists of about 100 million cells. I'm sorry, 100 billion cells, all working together and all connected to one another, so it's very intricate. Imagine trying to figure out how a machine works that you've never seen before. And it's got 100 billion parts.
Very confusing.
Think about the number of grains of sand on a beach. That's how many cells we're talking about. Watch how they know this stuff.
We can go back to the brain surgery to demonstrate the electrical nature of the nervous system. In addition to recording the brain's electrical activity, the surgeon will use another kind of electrode to introduce a small electric current into the patient's brain. In essence, he creates a nerve impulse that travels through her nervous system. The patient must be conscious to report the results of the doctor's probing. She feels little or no pain, for the brain has no pain receptors of its own. When you see her mouth open, it is because the doctor has stimulated an area of her brain that controls the mouth. She isn't moving it on her own. The patient may feel a tingling sensation somewhere else on her body instead. The impulse could even cause the patient to see things that aren't there, or hear music. The effect depends on the site of the stimulation.
How about that?
Do people just volunteer for that?
No, what those people are doing are they're having surgery to remove a tumor. And some people get brain tumors that can be potentially deadly, and you got to get them cut out. And what they do when they're going to go in there and cut it out, it's down deep in the brain, they got to make sure they're not cutting some part of the brain that's very important. And so they stimulate it, and they say, "You feel anything there?" And they say, "Yeah, I'm seeing a bright light." And the doctor goes, "Well, we're not going to cut there. They might not be able to see if we cut there." And so they move down a little bit, and they go, "Hey, should we cut here?" "No, I'm hearing music." "Okay, I'm not going to cut there." "Should we cut here?" "No, better not cut there." How about there?" "Nothing?" "Okay, let's cut there." Better was first.
Alright, you just threw me off. Never mind.
Yes, Sophie.
Like in Grey's Anatomy, this little boy was having brain surgery,
I'm just going to turn the
and
camera
he had to be awake.
Yes,
Because
that's
they didn't
exactly
know.
what they do.
And so they like showed him cards and was like, which was this picture, and
Exactly.
then he could do it. And then one time he like couldn't speak.
Stop talking, that's right, because part of
Yeah.
your brain controls speech.
And then he like started seizing and
Exactly. All right.
Pretty cool.
Program.
Pretty cool.
Right.
That was right.
You said that we use all of our brain, but when they poke it and nothing happens, it controls something, right?
Not necessarily.
Okay. Oh, okay.
And there may be something to do with something that we don't know.
Yeah, okay.
But apparently when they do cut through and they do remove the tumor, the people live their life okay.
Okay.
If they cut in the right place. So maybe not.
Got it.
EGF.
White. No, actually, it's just down really stupid.
Bennett.
In that video, was his head like
Her.
Yes.
pulled back?
Yes.
That was her brain.
Well, what they do is that, yeah, that was a brain. They cut out a piece of skull, take it off,
Like a half.
open up the skin, there's the brain.
Jeez.
Yes.
Why can't you remember stuff from when you were really little?
That's a good
We
question.
don't know that. It's called childhood amnesia. We talk about it in psychology class if you're interested. But we don't really know is the short answer. Yes.
Does the brain have to do with anything with shock? If you go into shock, does it have to,
You go, I don't know what exactly causes shock, but yeah, it's something to do with the brain. You're afraid and the brain kind of shuts down. And why that happens, I don't know. But yeah, it's the brain being shut down and you're not thinking like you should.
An answer.
Yes?
Like, if you had like a tumor up on the front part, how would they lay you down to get to the tumor on the front part?
Tumor.
Like,
They
if you're
set you up.
Oh, they have ways. They have machines. They can move your head in certain directions. They put you in a holder. They can get to it. Sometimes they go up through the nose.
Yeah, my mom's friend had brain surgery through her nose.
Yeah.
If the brain gets like too full of information, can it get rid of like stuff so it can?
Yes, it's called forgetting, and we do that. Yeah.
How do you do that?
We don't know.
Yeah.
We don't really know how the brain works. We don't know how memories work, so it's hard to answer questions like that. That's what they're studying right now.
How do you
It's come a
have
long way.
How do you have like a photographic memory?
Nobody knows. Some people do.
Actually, ask
People
God.
can store pictures better. There's a guy named Kim Peek. He's a savant, person who has an incredible memory,
What does the one?
and he can read a book that you might take 8 hours to read in 8 minutes. And he remembers 97% of it photographically.
Yeah, there's a
He
guy.
can repeat any phrase in the book.
Yeah.
I don't flip through every
There's a guy that he like read the New York City phone book and then like
Yeah,
somebody
knew all
told
the
him
numbers,
name
yeah.
and told him the phone number.
Yeah, like when like the most recent Harry Potter came out, there was like a guy in news who read Harry Potter in like 15 minutes.
Yeah, yeah. Yes.
When you have selective memory, is that like that whole part of the
yeah, I
brain?
think
Or
Yeah, memory is all over the brain, and we don't know how it works. Yeah, we're not sure how a lot of this works.
It was like
Take psychology, we study it for weeks.
It's like, oh, interesting.
Okay, coming back to this. Listen.
Whoa.
Oh,
bro. When the guy reads the book in 8 minutes, does he flip and look at every page, or does he
Yeah.
just go like
he
this?
flips and looks at every
flip
page.
300 pages.
You can see every word if you just.
I've seen him reading, it looks like this. He's got his head right here, and he goes. About that fast. He reads the left page with the left eye, the right page with the right eye.
No way.
Just a lie.
I didn't even know you could work both.
Most people can't.
Really? So it's like another
He can't.
thing he has on him?
Mhm.
He's gonna take over the world.
Actually, he just died in December.
Oh, really?
But the guy can't tie his shoes, he can't shave, he can't take care of himself. That's what savants are. They're real good at one thing and not good at others.
So why can't he
Doesn't know how.
Why doesn't he just
He
Why
can't.
why does he look
Can't
like
coordinate motions. You know, he's got all sorts of problems.
Big shot.
He doesn't understand
reading
cause and
book,
effect. If you said, man, it's smoking in here, he wouldn't think it's hot. He'd think there's smoke in here. So he doesn't understand. He's got a lot of deficiencies. No problem. You guys, is that your camera? I was gonna say because I broke mine.
You broke your camera?
Yeah. Well, I broke the battery on it, so it couldn't be used. So I'm gonna get a new battery. Okay, so read about the nervous system. Actually, we do want to talk about one thing. The nervous system is broke up into two major parts. We call it the somatic nervous system and the autonomic nervous system. Let me write these words down for you.
I'm gonna get down camera.
Somatic and autonomic. Now, the somatic nervous system is what you can consciously control. Ellen Grace up here. You can consciously control your muscles and move them. That means the somatic nervous system is in charge of that. Okay? I'm consciously controlling the movement of my mouth and my vocal cord. That's all somatic. Autonomic is stuff that you aren't in charge of. Your digestion of your food, for instance. The food is being pushed along right now. You aren't having to think, okay, let's push the food along a little further. That's good. Now let's squirt out some digestive juices. You don't have to think about that stuff. It happens automatically. That's why it's called autonomic. So somatic, you're in control, and autonomic, not in control.
So like the thing about falling down the stairs is that autonomic or whatever.
That's a reflex. That's actually below the thing.
So like telling yourself.
That's that's different. Yes, Vanessa.
So is blinking like both? All because.
Yes, both.
And then
Yeah.
What about breathing?
It's mostly autonomic, but you can
Sometimes,
control
yeah.
your breathing if you want to. You can say, okay, I'm going to breathe harder. So there are some somatic fibers.
Isn't there some kind of disease where you have to tell yourself to breathe? Like,
I don't know.
It might have been Grey's Anatomy.
no, I thought you were talking about it earlier in the year. Or is that in the book?
Not that I know of. Okay, listen. Let's think of this. The autonomic nervous system is broken into two divisions. We call it the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system controls what we call fight or flight. When you're suddenly scared of something, ah! Jump. Your sympathetic nervous system was just activated. You went into fight or flight mode. Your pupils dilate. All of this happens without your conscious thought. Your pupils dilate. Your liver squirts out sugar. Your muscles tense up. Your airways constrict. Your heart speeds up. All of this happens very quickly, and we call that fight or flight. You're ready to fight or flee. I saw it. Some of y'all jumped. Yeah. You were probably going to flee because you're like, Mr. Willis, I'm scared of him. The parasympathetic nervous system, listen, the parasympathetic nervous system is active when you're at rest. It's the opposite of the sympathetic. It's active when you're at rest. Everybody look at Tucker. Tucker is asleep. His parasympathetic nervous system is very active. Do you see the drool coming off of his mouth onto his book? That's what's going on. Exactly opposite of the sympathetic. The heart slows down. The breathing slows. The pupils constrict. They get smaller. The liver does not release glucose. And when I come up to him with this water gun and squirt it in his ear, oh, what's up?
Just let him do it. Let him do it.
I don't have a water gun. So, two systems. You control this, you don't control this. The autonomic nervous system is broken into fight or flight or rest, and they're different levels. These work against one another. So, this is all part of nervous system control. Make sure you read about it. It goes all the way through page 972. Okay? And this is your senses. We'll start talking about the senses tomorrow.
Willis
so
out.
you can go ahead and shut off. Willis out. We're going to watch.